Hi guys, today we're going to learn about the derivative of an inverse function. Let's start with inverse functions and review what you learned back in Algebra 2. A function g is the inverse of a function f if and only if f of g of x is equal to x for each x in the domain of g and g of f of x is equal to x for each x in the domain of f. The inverse of f is denoted f with this -1 at the top. Some of the properties that you need to remember from Algebra 2 are the following. If g is the inverse of f, then f is the inverse of g. The domain of f inverse is equal to the range of f original, and the range of f inverse is equal to the domain of f original. Please remember that not every function has an inverse, but if a function does have an inverse, the inverse is unique. Okay, so let's look at this example over here and do what we were doing back in Algebra 2. So we have f of x that it's equal to the square root of x minus 1. So what we need to do first is find the inverse function of f. If you remember this from Algebra 2, the first thing that you needed to do is set y equals to the equation that you have, that in this case it's the square root of x minus 1. After that, to find the inverse, we need to switch the x and the y. So you have that x is going to be equal to the square root of y minus 1. And then what we're going to do here is we're going to solve for y. Okay? So solving for y shouldn't be that variable. So you're going to square both sides, having x squared is equal to y minus 1. Then isolate the y, so you have that y is going to be x squared plus 1. So pretty much we find the inverse, so change the notation for the inverse notation. So you have that f inverse is going to be x squared plus 1. Okay? So that's what we have. Okay? I know that we need to be careful about the domain in a second, but that's what we're going to do for D. Okay? So then for B, what we have is we want to graph f and f inverse on the same set of coordinate axes. Okay, so we have the x, the y, and you're going to start with f. Okay, so we see f, and you know that the domain of that function, because we know that it's a square root function, it's going to be from 1 to infinity. Okay, so I'm going to plug the 1. You know that when we have the point, when we plug 1, we have that the output is 0. Okay, so that's my first point. The second point, that it's pretty user-friendly in this case, it will be 2. If you plug 2 there, 2 minus 1 is 1, the square root of 1 is just 1. So you know that that one is going to be at 2, 1, the point 2, 1 that we have over here. Another one that it's very user-friendly, and you can see it, it's if we plug x as 5. Okay, if we plug x as 5, so we have 2, 3, 4, 5, okay? So it's going to be 2, okay, because you know that it's going to be 5 minus 1 is 4, the square root of 4 is going to be 2. So that's what we have, and my hand is very shaky, but that's your f. Okay, this is f. Now, what are you going to do? Please remember that this point, it was 5,2. Okay, so to get the inverse, what you can do is you just flip the x and y, if you remember that from Algebra 2. So you have that for inverse, you have that it's going to be the point 0, 1. Okay, it's going to be the point 1, 2, and then it's going to be the point 2, 5. Okay, so we have that the inverse should look like this. Okay, so this is the inverse. Okay, so you can see the inverse and the original. Okay, so for B, C, okay, the graph. Okay, you can see the graph. For C, they tell you, hey, describe the relationship between the graph of f inverse and f. Okay, so what you can see, if you remember this from Algebra 2 as well, no worries, I'm going to refresh your memory here. So remember that we were doing pretty much the 45-degree angle line here, okay, with respect to the axis. Okay, so you have that this is y equals x, so you can see that it's a reflection, okay, the inverse is a reflection of the original, okay, over the line y equals x. So let's write it down. Okay, so you can see that the graph, okay, of f inverse, okay, is the reflection, okay, the reflection, okay, of the graph, okay, of f, okay, over, okay, the line y equals x, okay? So you can see that, okay? Then that's the description. Then for D, they tell you, hey, state the domain and range of original and inverse. So the domain of original, you know that the domain of original, we already mentioned that it's going to be from 1 to infinity, and this is inclusive, okay? And the range of original is going to be from, the lowest is 0, so you have from 0 to infinity, okay? Now, pretty easy to figure out what is the domain of the inverse, because we have several ways of finding it. Either you flip them, or you can also look at the graph. So both of them need to be consistent, obviously, okay? So the domain is going to be of inverse is going to be from 0, okay, to infinity, okay, which you can see that it's from 0 to infinity. And then the range of inverse is going to be from 1 to infinity, okay? So that's what we have for this problem, okay? So this is pretty much an algebra 2 problem. I'm just refreshing your memory because we're going to use all this situation, okay? So the next problem that we have over here, let me show you that one. We have that f of x is equal to x cubed, and then the inverse, they are giving it to you, and it's the cube root of x, which is not a surprise for us, right? So the next thing that they ask you to do is replace the x for 2 in original. So you have that it's 2 to the power of 3, which this is going to be 8, okay? For B, they tell you find the derivative of this guy. That one should be not a problem for via the power rule, so you have 3x squared, okay? After that, they tell you, hey, evaluate that derivative at x equals 2, so we're going to replace the x for the 2, so you have 4 times 3, that's 12, okay? After that, they tell you, hey, now evaluate the inverse at 8. Okay, when we plug the cube root of 8, that's going to be 2. So as you can see, my input here becomes the output here, and the output becomes the input here. Okay, so please note that we're going to use that fact a lot, okay, in a second. So they tell you what is the derivative of the inverse. Okay, by the way, it's called this. Okay, so use this notation. This is a new notation. You need to use it and love it because we're going to keep using it. Okay, so what's the derivative of this guy? The derivative of that guy, you know that via the power rule, is 1 over 3. Okay, x power negative 2 over 3. In other words, you have that it's 1 over 3x to the power of 2 over 3 here in the denominator. Whatever you prefer works. Okay, so lastly, they tell you, okay, so we have the derivative of the inverse at x. Now evaluate that at 8. Well, you know that if I plug the 8 there, technically speaking, what you have is the cube root, okay, of 8 squared, which is 64. So you know that the cube root of 64 is 4, so you have that it's 3 times 4, which is going to be 1 over 12. Okay, so you have that, okay, from the evaluation. Okay, so now ask yourself, what do you notice about your answers to C and F? Okay, so how they are connected? Well, you can see the 12, right? But it's in a different position. So what you can see here is that they are, okay, they're reciprocal, okay? Okay, so that's what we have, okay? That's our observation. Before I show you the actual formula, I want you to show you how we can develop this beautiful formula. So there's something very important that you know from Algebra 2. Okay, so from Algebra 2, okay, what you know is that f of f inverse of x is equal to x. Do you agree with that? If they are inverse of each other, okay? So we know that this is true from Algebra 2. So what we can do here in calculus is we can take the derivative, okay, of both sides. Do you agree with that? Because we want to find the derivative, okay? So you take the derivative of this. Careful with this one because you need a chain rule. So you take the derivative, okay, of this one using your best friend, the chain rule, okay, times the derivative of the inside. What's the derivative of the inside? Well, respecting the new notation that you just saw, we have this. Do you agree with that? This is via the chain rule. Chain rule, okay? And this is going to be equal, what's the derivative of x? 1, okay? So you have that. Now, if you want this, right? So let's solve for this one. What are you going to do to both sides? What we're going to do to both sides is pretty much we're going to divide both sides by f prime, f inverse of x. Do you agree with that? F prime inverse of x. Do you agree with that? So summarizing what I have, okay, so this cancels with this. So what I have is the derivative of the inverse evaluated at x is going to be 1 over f prime of f inverse at x. Isn't that nice? So this is the formula that we're going to see in a second. Isn't that nice? So this is how we can, you know, develop the formula, okay? Now that you understand where the formula comes from, that it's not that magical, okay, you know that the formula goes like this. If we have f, a function that is differentiable on an interval I, and f has an inverse function, f inverse, and f inverse is differentiable at any x for which f prime of f inverse of x is different than 0, we have that f inverse prime of a is going to be equal to 1 over f prime of f inverse of a at a. Please remember that if this is 0, then this does not exist, therefore the function, the inverse function, is not differentiable at that point, okay? So that's why we have this condition, okay? So as you can see, sometimes we're given all the pieces we need, and then we just have to put them together to get our answer. So in this question, they tell you, hey, f of 3 is equal to 5, and f prime of 3 is equal to 7 over 2. Find f inverse prime of 5. So what are you going to do here? First of all, you are like, how in the world I start this problem? Okay, so they gave you this. If they gave you that this is true, so you have the 0.35, okay? You know that the inverse must be the 0.53. So summarizing this with the notation that you learned back in Algebra 2, okay, we know that the inverse of 5 is going to be 3, right? Because that's what we have from here. With this being said, this is giving you a lot, even though maybe you haven't realized, maybe you have. Okay, so we have here, we apply the formula, okay, the inverse prime of, in this case, we want 5. Okay, so you know that using the formula exactly as it is, we have the inverse of 5. So now, you can see that, at least so far, I know that this is 3. So this is going to be equal to 1 over f prime of 3. Okay? Then you ask yourself, do we have f prime of 3? And the answer is yes, they gave it to you. So what we have is 1 over 7 over 2. Obviously, we don't want to leave it like that, so you just flip it. So you have 2 over 7, and that's your derivative of the inverse function evaluated at 5. Isn't that nice? So let's look at more problems. When we're not given all the pieces, we need to find some of the pieces, such as the f inverse evaluated at a, and maybe the derivative, okay, before we can use the formula. So we have this equation, let f of x be equal to x power 3 plus 2x minus 1. They want you to find the derivative of the inverse evaluated at 2. So the first thing that I would do, so you know what you have and what you need, I would apply everything in the formula. Okay, so you have something that looks like this. So think about something. I want something that gives me the output f of something that gives me the output 2. So this is what I want, something that gives me the output 2. Okay, why? Because I want f inverse of 2 being equal to that something that I don't have. Do you agree with that? So let's deal with that first. What number, when you plug it here, gives you 2? You start with 0 because that's a natural idea, right? If you plug 0, that gives you negative 1? No. If you plug negative 1, that's not giving you 2, so game over. If you plug 1, what happens? You plug 1 and that gives you 3 minus 1, that's a 2. So if you plug 1, that gives you 2. Therefore, f inverse of 2 is going to be 1. So pretty much we are doing a trial and error here, okay, which is easier than actually finding the inverse of this, okay? Do you see it? Now after that, what we're going to do here is we're going to find the derivative, okay, of f, which is going to be 3x squared plus 2, okay? So you can see that here, okay, we have 1 over f prime, and then you have the f inverse of 2, which is 1. So now we need the derivative evaluated at 1. So you go ahead, evaluate at 1 your derivative, and you have this beautiful number that it's 5. Yes? So you have that this is 1 over 5, okay, and that's going to be the derivative of the inverse evaluated at 2, okay? So let's look at this problem. This one, technically speaking, finding the inverse wouldn't be that difficult, right? But let's do it the calculus way, okay? So what you're going to ask yourself is, I want this, okay? So you have the inverse, okay, derivative evaluated at 2. So what you have is 1 over, and you have g prime of g inverse evaluated at 2, right? Okay, so what we want here, there's several things that we want. Obviously the derivative, okay, which we can find it, no problem. And then the second thing that you want, like the problem before, we want which number at g gives you 2, okay, because we know that g inverse of 2 will give you that value that we are trying to find. Here it's pretty easy to do the trial and error. You can see that if I plug there 3, that will give me a 4, and the square root of 4 is 2. So that's 3, and this would be 3. Therefore, you have here that it will be 1 over g prime, and you have the 3 here, and then you see the need of the derivative. Okay, I take the derivative of this guy, which I know that it's going to be 1/2 x plus 1 to the power of negative 1/2 times 1 with the chain rule. So you have that it's 1 over 2 times the square root of x plus 1. Okay. Then you just pretty much take the 3 and replace it for the x. So you do have that it's 1 over 2 times what? Root 4. So you know that that's going to be a 1 over 4. Therefore, you have that this is going to be 1 over 1 over 4. Therefore, your answer is going to be 4 for this question. Okay? Isn't that nice? Okay, so let's move on to the last problem of the day. Okay, so you have f of x is equal to cosine x, and then they tell you that the x is only half of the unit circle, okay, and they want you to find the inverse derivative at root 3 over 2. So what we have is we have the inverse prime, okay, at root 3 over 2, and you know that this is going to be equal to 1 over, and it's going to be f prime of f inverse evaluated at root 3 over 2. So what do you want here? You want, again, two things. First, the derivative. Secondly, what do you want here? You want the function f that gives you as the output root 3 over 2, right? Because what you want is you want the inverse root 3 over 2, okay, that value, okay? So you ask yourself, my derivative is cosine. So when cosine of x is equal to root 3 over 2, you know that this is on the unit circle, quadrant 1, pi over 6, right? So you have that it's going to be pi over 6 here and here. Therefore, you have here one step further, f prime of pi over 6, because you know that this thing over here, it's pi over 6. So you're like, okay, let's take the derivative. The derivative of cosine x is just negative sine of x, which is super user-friendly. So you know that f prime of pi over 6 is going to be equal to negative sine of pi over 6. From the unit circle, you know that sine of pi over 6 is 1/2. With the negative in front, this is negative 1/2. Therefore, you plug it here, 1 over negative 1/2, and this is going to be equal to negative 2. And that's pretty much it. Isn't that nice? I hope that you find this video helpful. Bye!